using a substitution. We solved systems using an elimination. And we only had an x and a y that we needed to solve for. So now what's going to happen in section 4.2, we're going to add in a third variable. And since it's a z. And since you add in a third variable, that means you need to add in a third equation. So depending on how many unknowns you have, that's how many equations you need to be able to solve for all of the unknown variables. Okay? So we're just going to be doing a 3 by 3, meaning 3 unknowns, 3 equations for solving y's. And we're not going to graph them. We're not even going to get into graphing into a 3-dimensional coordinate plane. So we're either going to use substitution method or elimination. Okay? All ready? Okay, so when you solve a 3 by 3 system, your answer is now, instead of an ordered pair, go ahead. It's going to be a tripled order. And it goes in the order of x, comma, y, comma, z. So instead of an ordered pair, we have a tripled order. Not an order tripled, a tripled order. Okay? So again, it goes alphabetically, so it's x, y, z for your final answer. We'll make it fancy by putting our set notation around it. All right, so let's just go ahead and start solving. So here's our first system. Take a moment to write it down. We've got 4x plus 8y plus z equals 2. Second equation, x plus 7y minus 3z equals negative 14. Yep, you would have done these in algebra too. 2x minus 3y plus 2z equals 3. Not in algebra 1. All right, so this is how I do this to organize my thoughts, because I consider myself a pretty organized person. I put numbers in front of each line, so then as I'm talking and thinking, I'm thinking either line 1, line 2, or line 3. Okay? So I always usually just use the elimination method. The only time I would use substitution is if any of my lines had a variable already solved for, which in this case, there is no isolated variable anywhere, right? So now I'm looking for a variable, whether it's an x or a y or a z, that has a coefficient of a positive 1 somewhere. Do I have any that have positive 1s? Well, here's a z with a positive 1. Here I have an x with a positive 1, and that's about it. So I'm going to try to either eliminate an x or a z first. You're going to go with x? Okay, so if I look at line 2, I can either eliminate it with line 3, which is a 2x, or I can eliminate it with line 1, which is a 4x. There's no right or wrong answer. The 2x, smaller numbers, right? So if I want to combine 2 and 3 together, what do I need to multiply line 2 by to eliminate the x's? Negative 2. Okay, so I'm going to multiply line 2 by negative 2. I'm going to shift everything over to the right. So that becomes negative 2x minus 14y plus 6z. And please make sure I don't miss a negative somewhere. And then that would be a positive 28. I'm going to rewrite line 3 directly below it. 2x minus 3y plus 2z equals 3. I know it's a bit tedious to rewrite everything, but it keeps you from not making mistakes if you write it all out. Okay, add up and down. X's go away. Y's become negative 17y plus 8z equals 31. Okay, well now I have an equation with just 2 variables, which is good, because I know how to solve that. So now I need to get another equation. So I have 2 unknowns. When I have 2 unknowns, I need 2 equations, so I need to get a second one. So I used line 2 and line 3. The only other one I haven't used yet is line 1. So now I need to use line 1 to get rid of my x. I can either combine it with 1 and 2 or 1 and 3. Which one would you prefer? There's no right or wrong. With 3? Okay. So if I combine it with 3, what would I need to multiply 3 by to eliminate my x's? Negative 2. So I'm going to rewrite line 1 down here. So 4x plus y plus z is equal to 2. And I'm going to multiply everything in line 3 by a negative 2. So that gets me a negative 4x. Negative 2 times negative 3 gets me a positive 6y. Go ahead, Abby.
Oh, I was just saying positive 6y.
Yeah, minus 4z equals negative 6. Add that straight up and down. So my x's go away. 8 plus 6 is 14y. 1z minus 4z is minus 3z. I have a negative 4. So now I have an equation with a y and a z here. I have an equation with a y and a z here. So now I can combine those together. So I'm going to transfer that one to underneath the negative 17y. So 14y minus 3z is equal to, not 31, what am I talking about? Negative 4. So I'm just moving this up here. Okay. Ugh. Those are ugly numbers. You want to get rid of the y or the z? Definitely the z, right? What can I turn 8 and 3 both into?
16.
No. I have to do 24, right? So I'm going to have to multiply, I'll do this in a different color. To multiply this by a 3, I'm going to multiply this by an 8. They already are opposite in sign, so that's okay. So 17 times 3, I don't feel like doing mental math right now. I probably could figure it out by now. 51, so negative 51y plus 24z is equal to 93. 8 times 14 is 112y minus 24z equals negative 32. Negative 51 plus 112 is 61y. Well, z's go away. 93 minus 32 is what? 61? Oh, well, that's nice. So y is equal to 1. Okay. We got 1 done. How am I going to get this z? Which one do you want to plug that 1 in for y, this top equation or the bottom one? Top one? Okay. There's no incorrect answer. Well, negative 17 times 1 is negative 17 plus 8z equals, you were saying y in there, equals 31. 31 plus 17 is 48. What's 48 divided by 8?
6.
Good. So z is equal to 6.
Now we just plug both of them.
Now I'll go back to the originals.
4 times 6 is 24. 24 plus...
Well, we don't have an x. I have a z and I have a y.
Oh.
So Abby's going back to line 1.
8 plus 6.
So 4x plus 8 times 1, which is 8, plus 6 equals 2. So I'm just plugging in my y and I'm plugging in my z. 8 plus 6 is 14 equals 2. Subtract 14 gets us 4x equals negative 12. So x is equal to negative 3. Whew. So my answer as a tripled order
Is the parentheses...
negative 3 for my x. My y is 1. And my z is 6.
Now we do the squiggly.
Do the squigglies to make it fancy. It's a lot of work, huh? So that's why it's very, very important to keep yourself very organized so you don't get lost and then you're just kind of like, I have no idea what's going on. That happens. And you don't want that to be the case. All right, let's do a special one yet because I know it does take a lot of time. I just want to make sure the next one I have is a special one. That one's not a special one. That's a fractions. All right, can I erase this?
Yeah.
So what am I looking for? Yes, this one. All right, so 2x minus 4y plus 6z equals 5. Negative x plus 3y minus 2z equals negative 1. X minus 2y plus 3z equals 1. Now, whenever you have the special systems, these are going to be your best friends because you're going to get to a point where you realize I can't go any further because my variables have canceled out early on, so they're a lot less work, which makes it nice. You don't have to go all the way through everything. So I'm going to label 1, 2, 3, just so that when we're talking, we all are on the same page. Now what's nice about this? Look at 2 and 3. What eliminates right away?
X, right away.
Right away. That's nice, right?
Yeah.
So because they eliminate right away, I'm just going to put like a combo arrow of those two. My x's go away. What happens to my y's? 3y minus 2y would be 1y. Negative 2z plus 3z is 1z. And I get 0. So now I have an equation with a y plus a z. So that means I need a second equation with a y and a z. I used 2 and 3, so what's the one I haven't touched yet? 1. So now I need to either combine 1 and 2 or 1 and 3 to eliminate the x. 1 and 2, multiply line 2 by what? Positive 2, because it's already negative. Good. So I'm going to rewrite line 1 down here. So 2x minus 4y plus 6z equals 5. And then my new line 2 would be negative 2x plus 6y minus 4z equals negative 2. So what do we got?
2y plus 2z
Yep.
equals 3.
Good. So I'm going to move that up here. So 2y plus 2z equals 3. Multiply line 1 by negative 2. Do this in a different color. So multiply that by negative 2. So now I get negative 2y minus 2z equals 0. So now what happens?
They all cancel out.
So I end up with 0 equals 3.
That's incorrect, so it's not a thing.
No solution. Good.
Yeah.
So now I'm done.
And we forget the squiggles are on our 0 with an X there. Do you get a point sign?
I won't, but try not to forget them. Gotta fancy it up. It's like wearing a jean jacket with no...
Pants.
What was it called when you stapled the rhinestones on it?
Bedazzled.
Bedazzledness. Yeah.
Yeah.
Could you wear a jean jacket without it being bedazzled? I don't know. Now, what would happen if this ended up being 0 equals 0?
Then it would be all real.
Then it would be all real numbers. So let's pretend that it ended up as 0 equals 0, right? Then our solution would be the set of x, comma, y, comma, z such that, and then we would go over here and find the most simplified standard form.
X minus 2y.
Sure, x minus 2y plus 3z equals 1.
Yeah.
Okay? So if you end up with one that has 0 equals 0, then your answer is going to be the set of the triple order such that, and then pick your most simplified standard form equation up there.
Will you avoid doing that to us on the quiz? Or are you just
The homework quiz?
both?
Well, wouldn't it be easier to end up with a no solution than going all the way through?
No, I like the no solutions, not all.
Oh, the all real numbers?
So then I'm gonna have to remember how to write it off, and I know I'll